All right, so kind of some bad news. I got cut off again for like 15 minutes of this video, so I got to do it again. It looks like I got cut off on after I just got done with number 11. Good news. So all that hard work I did after that was not caught, so I got to do it again. So we're going to go on to number 12. Which I don't mind. I don't mind doing it again. I like these problems. So this one says find the exact value. So cosine 7 pi over 9, cosine 2 pi over 9, minus sine of 7 pi over 9, and sine of 2 pi over 9. Okay, so kind of a cool problem. We can actually figure out the exact value. Now this is in radians now, and the kind of key is I want to figure out what is this close to? What identity is this actually using? So it's actually using this identity here. This cosine of A plus B was cosine of A, cosine of B, minus sine A, sine B. But it's actually using it kind of in the opposite direction. So kind of going from here to here. And the A is the 7 pi over 9 radians, and the B is the 2 pi over 9 radians. Okay. So if I were to rewrite this, this is actually cosine of 7 pi over 9 plus 2 pi over 9, kind of using our identity in reverse. What's 7 pi over 9 plus 2 pi over 9? Well, that's cosine of, say, 9 pi over 9. And this is a cosine of pi. And cosine of pi is negative 1. Okay, so if I think about pi radians, 2 pi radians is all the way around. Pi radians would be right here. Negative 1 comma 0. Cosine is the x-coordinate. Cosine of pi is negative 1. Okay. So I can actually tell you what this exact expression is equal to. Interesting thing is I wouldn't be able to tell you what any of these four are equal to. Like I have no idea what cosine of 7 pi over 9 is. No idea whatsoever. But as a whole, because of this identity, I can actually tell you what this value is. Okay? And if you were to put this in a calculator and you were in a radian mode, you could get it too. But the idea is to use identities to try to figure that out. Okay? All right. So, going on to some problems. This. And this one says use identities to write the expression as a function of theta. And our expression is cosine of 180 degrees minus theta. Okay, so I have something like this. What they're really wanting you to do is just use that difference identity and go through and simplify this. So the difference identity for cosine. So this is a cosine of 180. Cosine of theta, and then this becomes a plus now, sine of 180 sine of theta. Okay, what's cosine of 180? Well, that's cosine of 180 degrees is negative 1. What's the sine of 180 degrees? It's 0. So if I plug those values in, this is really just negative cosine of theta plus 0. So I really just get negative cosine theta. Okay. Let's look at 46. So 46. This one, I'm going to mix it up. We got cosine of, say, 270 degrees plus theta. And they say to use our identity for the sum of cosine. So this is cosine of, say, 270, cosine of theta The plus would become a minus, and this would be sine of 270 sine of theta. So by our identity. And then what's cosine of 270? That is actually just 0. And if you don't know this, you can use calculator or kind of use your unit circle. Sine of 270 is -1. So this is 0, and this is really plus sine theta. So the whole thing is really just sine theta. Kind of neat. And now it's a function of theta. They consider this to be, really this is a function of theta too, but the argument is 270 plus theta. So saying this is nicer because the argument is just the angle theta instead of 270 plus theta as it was before. Okay, really there's just a couple other problems that I want to do. And this next one, I'm just going to do one of these, and I'm going to hope that is enough to get the idea of what you want to do. But if it's not, then ask me questions. But this is one where you're given two different angles. You're given information about two different angles, and you want to go through and find the value of a sum of those two angles, of a sine or cosine. Okay, just to give you an idea, this is number 49. And they're using S and T instead of that because those are hard for me to draw. I'm going to use theta and alpha. So I'm going to say that the sine of theta is 3/5 and sine of alpha is -12/13. And we're told that theta is in quad 1. And we're told that alpha is in quad 3. So two different angles, two different quadrants. Okay. So I want to make a picture for angle theta, and I want to make a picture for angle alpha. So for angle theta, theta is in quadrant 1, so I'm going to have something like this. And I drop it like it's hot, so I draw this right triangle. And I'm also told that sine is 3/5. So y over r is 3/5. Now, you may be able to figure out this value, which we need to do. There were a couple ways. I could call it x and do x squared plus 3 squared equals 5 squared and go through and figure out that's 4, or just remember your 3, 4, 5. And it's got to be 4 because we're in quad 1. It's positive. So that's your picture for angle theta. Also got to make a picture for angle alpha. Now alpha is in quadrant 3. So it's down here. And there's alpha. Make sure that I'm on the screen. Okay, there we go. And then I'm going to drop it like it's hot. Right? Here's my perpendicular. Sine of alpha is -12/13. So that means my y is -12 and my r is 13, and maybe I got to go through and find x. So you could know it, or you could just do it the way we did before. Do x squared plus -12 squared is equal to 13 squared. Okay, make sure that's in there. Yep. So I got x squared plus 144 is equal to 169. X squared is 25. So when I take the square root, is it going to be plus or minus 5? Well, since x is in quadrant 3 here, it's negative. That's going to be a -5. Right? If I go through and take the square root, I pick the negative square root because x is negative in quad 3. So that's our picture for alpha and our picture for theta. That's kind of the first thing that I would do. And then the question, I actually haven't even asked the question yet, but the question is to find cosine of theta plus alpha. So they ask us to find this value. And cosine of theta plus alpha, well, I don't have a lot of information of theta plus alpha. I have information about theta and alpha individually. So the idea is to use that identity. I know that cosine of theta plus alpha is cosine of theta cosine of alpha, plus becomes a minus sine theta sine alpha. And when we're plugging these in, just keep in mind you're plugging like the fraction in. So like I know that the sine of theta is 3/5. I know that the sine of alpha is negative 12/13. What's the cosine of theta? Well, to figure that out, I got to use this picture, right? What's cosine of theta? That's 4/5, right? X over R. What's the cosine of alpha? Well, that looks like it's negative 5/13, right? So cosine of alpha is negative 5/13. Cosine of theta is 4/5. I plug all those values in. So cosine of theta was 4/5. Just plug 4/5 in for cosine theta. Cosine alpha is negative 5/13. Okay, sine of theta was up here. That was 3/5. And sine of alpha was negative 12/13. So I plug all that stuff in. So what does this simplify to? Well, this is negative 20 over 65. And negative 3 times negative 12 is plus 36 over 65. So fortunately, we have a common denominator. If I add those two together, I do get 16 over 65. And that doesn't simplify. That would be my answer to this question. That is what that value is. Can you do this with a calculator? No. This is one where you're actually going to have to do this work. Okay, and it's kind of time consuming, so I'm not going to do a ton of examples. But it's the same idea every time. You draw a picture for your two angles. You write down your identity. You plug everything in. Okay, but if you have any questions, I'm going to give someone Alex where you got to do this. Just ask me. And, okay, so that's 49. And then I want to show you just kind of one identity, just to show you like an example of kind of an easy question now. So where it says 63, verify the identity. And it's something like cosine of pi over 2 plus x is equal to negative sine x. Well, I would pick the left-hand side, because I can use my identity for that. So I pick left-hand side and I go, okay, cosine of pi over 2 plus x, and that's equal to cosine of pi over 2 cosine of x and minus sine of pi over 2 sine of x, using our identity. What's cosine of pi over 2? Well, that's going to be 0. And what's the sine of pi over 2? That's going to be 1. So this whole thing is really just negative sine x. Okay, that's how I would verify the identity. Okay, I have one for you to think about. So just to make sure you're going through to the end of the video, what I would like you to do is, for extra credit, you can do this identity. Let's see if you get all the way to the end of this video. And this is to verify that cosine of 2x is cosine squared x minus sine squared x. Very useful identity that we're going to talk more about, but this is the first time we can actually kind of show it. And my hint would be cosine of 2x is cosine of x plus x. That seems kind of obvious, but I hope that hint is helpful. So if you go through and scratch piece of paper, write out verifying that identity. I will give you some extra credit for this quiz on the 5.3 and 5.4 that you're going to have. Okay, so that is it for the cosine. Then I wanted to do a couple for the sine. Now, I'm not going to do a ton because it's the exact kind of same idea. And there are also identities for the tangent, and I'm not going to do those. Okay. But I want to show you one like this. So let's do a couple with sine. So recall, this is 5.4. Sine of A plus B is sine of A cosine of B. And this is plus cosine of A sine of B. And we also have that the sine of A minus B is the sine of A cosine of B minus the cosine of A sine of B. Sine, cos, cosine. Again, don't need to memorize, but that's what we're going to use in 5.4 for the most part. Okay. All right. Let's find sine of 15. So the idea is, I think of this as the sum or difference of like 30, 45, 60 degree angles. A couple different ways actually to do this one, but maybe I think of 15 as 40 minus 35. Or sorry, 45 minus 30. That's what I meant to say. Sine of 45 degrees minus 30 degrees. That would be the same as 15. And then I use my difference identity for sine. So this is going to be sine of 45 cosine of 30. And sine stays the same, so that's a minus cosine of 45 sine of 30. Now, remember with this, we're trying to find the exact value is what we're after. So sine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. And sine of 30 is 1/2. So this is root 6 over 4 minus root 2 over 4. And that's root 6 minus root 2 over 4. So we got a common denominator. That value should look familiar because I think in the other video I found cosine of 75. Well, cosine of 75 is going to be sine of 15 by our cofunction identity. Okay. But this is kind of how I would find exact kind of same reasoning. I'm just using a different formula. So I am not going to behoove this. I am going to trust that you can use those identities. I am going to do one of the verifying identities, but everything else, I'm going to trust that you can manipulate these kind of like we did with the cosine and to just give you some problems on it, okay? Because it really is the same kind of idea. And I want to do verifying 57. So sine of 2x is 2 sine x cosine x. I want to verify this identity. Very useful identity, going to come up a lot in calculus. Okay, sine of 2x is 2 sine x cosine x. Pick the left-hand side. So the sine of 2x is the same as the sine of x plus x. So I think of 2x as x plus x. And then the idea is I can use now my sum identity. So this is sine of x plus x is going to be sine of x, cosine of x. So my a and b are like the same. Plus cosine of x, sine of x, right? What's sine x, cosine x plus cosine x, sine x? That's just 2 sine x, cosine x, since they're like terms. And that would be my identity right there. Okay, so I think that will be enough for this week. I know I've given you a lot. I'm sorry. But hopefully this week goes well for you. And And we get through this. We're almost through chapter 5. I just got 5. And right there, this is a segue into chapter 5. This is something called a double angle identity. Because instead of talking about sine of x, I'm talking about sine of 2x. And that is the last thing we got to talk about in chapter 5. So I'll see you.